Hope you all had a nice break. Today we're going to do another final day of it says test, but it's just a quiz tomorrow. Quiz review. So today we're going to go through pages 9 and 10. I have a additional worksheet here. Okay, so page 9. Let's start with number 1, part A. It says, let R be the region in the first quadrant enclosed by the graph y equals 2x and y equals x squared. So the curve is the x squared and the linear is 2x. Find the area of R. So we always want to try to do top minus bottom first because that's the more convenient one. So it looks like we can draw one representative rectangle, and that rectangle can be consistent all the way through. So we see the top of our rectangle touching the linear, which is 2x, and the bottom is touching the x squared. And then our x values are from 0 to 2, because we're stacking these rectangles from furthest left to furthest right. Everything's in terms of x. Okay. And then when we do area, we don't do any other, we don't add anything to this. There's no pi, there's no parentheses squared, right? That's volume, that's washer or disk or cross section. Okay, so we can plug this in our calculator. This problem is meant to be non-calculator, but tomorrow on the quiz, you'll be able to do everything with the calculator. But if it's non-calculator, that means, work this out by hand. We go through power rule, plug in upper and lower bound, but on the quiz, you'll get to just plug in the calculator. But I wanted to give you an idea that there are times when non-calculator problems within area volume can exist. So on the AP exam, sometimes you have a problem that is calculator, sometimes it's non-calculator. If it's non-calculator, then this is what we would want to go through. Okay, so if you want to plug in the calculator, you will do math 9, definite integral from 0 to 2, and then 2x minus x squared dx. You get 4 thirds. Yeah, this one we can say unit squared, but just like on the P exam, if they don't ask you for units, they can't take off points for units. Yeah. Yes, you're right. This is area, so if it's centimeters, then it'll be centimeters squared. Units. Okay. Any questions with part A? Okay, part B. The region R is the base of a solid. The cross section perpendicular to the x-axis has area. Find the volume of the solid. So we know this is a cross section problem, and let me just remind us, volume of cross section. B is equal to the integral of, it's going to be whatever the area is, right? And that area could be rectangle, could be a square, could be equilateral triangle, could be right triangle with leg on the base or hypotenuse on the base or a semicircle. So there's all these different shapes, but part B, first we need to figure out which direction is this dealing in here. So perpendicular to the x-axis, which orientation is that? Vertical, right? X-axis is horizontal, so we always pay attention to that's going to be your anchor, and then in relation to that horizontal axis, you want something that is perpendicular, so it's got to be a different direction, so it's going to be vertical. So it's going to look like this, even though we have uh, different frame of reference, right? Part A, we're just finding area. Part B, we're building these areas on top of this. Now, do they tell us what shape that we're building? All they told us is what? Is the area, right? So do we need to make any adjustment to this? This just goes directly in. There's no need to worry about, okay, figuring out the base and then base squared, root 3 over 4 base squared. If they sometimes the problem would just give you that cross-section area and you have to insert that directly in. So in this case, we don't have to worry about the shape because the area is already provided. What are the bounds going to be? Same as before, right? X value 0 to 2. Normally, this would be a U substitution problem with your U value being pi over 2x, which will produce a coefficient of 2 over pi after the whole U substitution. But your calculator can handle this. But as a reminder, anytime we have U substitution, basically whatever coefficient that you see, as long as it's linear, what's going to come out is the reciprocal. So that's just a nice reminder of the fact that U substitution is chain rule, but going the reverse direction. So that's why it's not times pi over 2, it's times 2 over pi. But in your calculator, if you get a decimal version of this answer, that will be fine as well. So it's going to be like 1 point something. Okay, part C. Another solid has the same base R, For this solid, the cross-section is perpendicular to the y-axis, okay? And now we're dealing with shapes. Now we're dealing with squares. Right, but do not evaluate an integral expression for the volume solid. So this one is also going to be cross-section, but this is going to be more familiar or more similar to the ones that we've seen in the past. Okay, so let's figure out which direction is this. Perpendicular to the y-axis. The y-axis is which direction? Vertical. Perpendicular to it means we want something that is horizontal. So anytime we see a horizontal base, a horizontal rectangle, a horizontal radius, we got to do what? Yeah, spend time to rewrite our equation, right? So this was y equals x squared. Got to algebraically move things around to solve for x. So x equals what? X squared of y, yeah. Technically it's plus or minus, but first quadrant, so we can just leave it as positive. This line was y equals 2x. Y over 2. Write it better here. Okay, let's build our base. Base length is right minus left. The right endpoint is sitting at the root y. The left endpoint is sitting at the y over 2. Now we have to build the square component. What's the formula for square? Area is what? Or just base times base, right? Base squared, right? The height is going to be the same as the base because the square has the same dimension, length, and width. So base squared. So therefore, root y minus y over 2 squared. So we're not going to change this in our volume formula. Really, to go from here to the third dimension, you're just going to bookend on both sides with integral and dy. Right? But we have to worry about the bounds, though. Where are the bounds that we want to choose? 0 to 4, right? Lowest to highest y values. We're stacking these squares from this end to the other end up here. And you'll use x in your calculator. The directions only say to set it up, but we have a calculator. That's why we can plug it in. But the reason why it says to set up, because this is technically a non-calculator question, and they don't want to have to make students go through the whole power rule process, expanding all the way through. So that's why they left it as just set up.
So you're referring to a non-calculator problem that you, like, we tried non-calculator.
Sorry?
You're referring to non-calculator problems that we, like, tried non-calculator on, that's not something we take the rate base exam, or like.
Yeah, so we will work on some problems that are, I mean, I guess now we're getting a taste of non-calculator, but I wanted you guys to have a calculator on the quiz. So yeah, I think the only complexity with non-calculator is having to worry about use substitution, where on the calculator you don't have to. but we'll get some practice with that. Okay, I got 0.533. Is that what you guys got? In part D, write an integral expression that gives the volume of the solid generated when the radius is rotated, or when the region R is rotated about the line x equals -1. So this is a horizontal or vertical line here. Vertical line, okay? And because there's rotation going on, this has to be either which method? Either washer or disk, but there is no flat surface here, so this has gotta be washer, yeah. Okay, so let's set it up.
It's old washer.
I'm sorry?
And how it was like 2 lines, like 2, you have to do 2 lines across. So like the little line there one.
That's right, yeah, that's right, yeah. Anytime you have to draw 2 radius, it's always washer method, that's right. And we know it's washer method because the dotted line is not up against the flat surface of the shaded region. And we're going to be experiencing horizontal radius, but we've gathered a lot of information that we need from part C, so we can pull that information down. And I want to keep reminding us that even if the dotted line was touching the shaded region, if you see any sort of a gap, it is still going to be washer method. Right? So this shaded region has no flat surface, at least not from a horizontal or vertical perspective, right? I mean, there's technically a flat surface here, but it's diagonal, so but our axis is always going to be vertical or horizontal. So this shape is never going to allow for anything but washer method. We have to build 2 radius, big R and little r. Okay, right minus left. What's the right endpoint of big radius sitting on? Y. Minus, what's the left endpoint of big radius sitting on? Yep, so minus a -1, right? Okay, small radius. Right endpoint minus left. The right endpoint is sitting on the linear, which has been rewritten as y/2. Again, minus a -1. So this is rotation is always going to create these circular shapes. So here we will have pi in front. Bounds is still from 0 to 4. We're stacking from lowest to highest y value. I know this problem is only asking for the setup, but in practice entering this in our calculator, I would do let root x plus 1 be y1 and let this be y2, and then put it in math 9 after you have it all set up. Okay, page 10. I'd like for you guys to try these three problems on your own. See if you can set it up and if you're having trouble deciding which one is which, think about 2x squared, right? That's a parabola that opens what? How does it open? Up, yeah, it's positive, right? So you know that this 2x squared is going to be this one here. Okay. Again, we're just practicing with a non-calculator question, but the key has it all worked out using use substitution, but you can use your calculator for this. Do top minus bottom, just make sure that we protect the bottom with a set of parentheses, otherwise, if the negative doesn't distribute through, then we're gonna get different answers. And part B, we know it's gonna be washer method. There is no flat surface, so even though it's touching, there's still that gap that we have to subtract out. So we extend from the dotted line to the furthest boundary, that's your big R. Dotted line to the closer boundary, that's little r, big R. As long as you put them next to each other, big R will always be longer in length than little r. Top minus bottom, don't need to change the bounds, no need to change the equation. Keep everything the way it is. Make sure you're squaring your radius separately, plug in the calculator. Get you 18.344 pi. Double check my work. Yeah, just right, yeah. But on the calculator, I'm sorry, on the quiz, I may ask you to go further, so I can practice that. But yeah, the direction only says to set it up, and that's because it's non-calculator. It would never ask you to work all that by hand. Okay, part C, we have a cross-section problem here. Build your base, or decide which direction to build your base, then build your base, then build the area formula, and then make it into an interval to get to that third dimension. Okay, so part C says cross-section is perpendicular to the x-axis. So let's think about that. X-axis is horizontal, perpendicular. It's going to force it vertical. And then we just do top minus bottom to get the base length. Once you get the base length, know that the area of a square is base squared. So we turn that one-dimensional into a two-dimensional. And then from two-dimensional, three-dimensional, we just put the integral notation on either side. So, but don't make any changes to your area. You've already built your area the way it's supposed to be. additional time, so I wanna, this is a worksheet that I was gonna just use for help session this morning, but I'm going to. We don't, no, we just take one this one. Happy Friday, by the way. Wrong, because we're actually using by this. We're actually using by this. Right. I'll get it. The keys attached, but one thing that I want to do before we try some of these problems. Any questions though? Are we okay with this page here? Is I want to just this is on page 20 of your of your previous packet. I don't think did I put this on your quiz review? I don't think. Good. Good. All right. So this is also on your quiz review packet. Just want to review these formulas here. So remember with cross section area, all these basically have base squared except for rectangle. Rectangle is base times height. So tonight make sure you go through and remember the coefficient, memorize the coefficient in front of the base squared. A sausage right triangle with leg on base is 1/2. Sausage right triangle with hypotenuse on base is 1/4. Equilateral triangle is √3/4, and then semicircle is power/8. So let's just see if we can run through these and see how we do with these. So area of a square is what? A squared, okay. Isosceles right triangle with leg on a base, 1/2 a squared. Isosceles right triangle with hypotenuse on the base, 1/4. Rectangle, base times height. Equilateral triangle, yeah, √3/4 base squared. Semicircle, power/8. Okay, so you basically pretty much know it. So tonight, tomorrow morning, you just have to do a quick review, make sure that you're good with all those formulas. So so go ahead and try number one. It says write equation of tangent line, so that's review from the previous. That just means find the order pair, find the slope, and then point slope form. Okay, the keys attached. I know I'm missing some copies, so I'm gonna make some copies while you guys find them.
They could take a few minutes after the.
You can break that, right?
2 hours.
Last year was terrible, we too, it's been a school after. After the classes. I'm gonna try to do the trip. I'm still very done up and out of town, like, at least one day every week since like end of January. I started getting email. The TV started going. But I do it, it's not that cool. That's great.
It doesn't even on Monday, it's a week after one.
Anyone else missing a copy? Say it again, how did it was?
That's the root theory.
Oh, cube root, math 4, math 4.
I don't know if you're using the x-axis or y-axis as well. Speaking
X-axis,
like the x or y value.
Oh, you mean, having to rewrite the equation?
Yeah.
Okay. Anytime you see a vertical base, vertical, radius, vertical, anything, you know, no adjustment needed, you just reline. But anything you see horizontal, then you gotta rewrite your equation. So, yeah, so if you see a horizontal anything, it's gonna have to be rewritten.
Okay.
Okay, so good with page 1, go to page 2.
So,
I thought it meant like.
part A is just write the equation, it's just that's a previous, topic. It's just gathering order pair, slope, and plus slope. There's no, we don't do anything until part B.
Like this one?
So it's just finding the pair. Plug 1/2 in for X. If you have 1/2, if you have the X value, you can find the Y value. The Y value.
And that's all you need really get the whole thing, right?
Yeah.
Another one.
And then next thing you can find this, the derivative. From the derivative, find the slope. So F prime.
And you plug in,
1/2 in here should get the slope.
uh,
And if you plus the Y minus Y1, it takes you out.
okay.
Okay, so that's just, what I just gave you is just additional worksheet, practice if you want to do that tonight. But, back to your quiz review, page 11 to 13, I'm going to, go through those pages tomorrow, but I think this is a really good, um, representation of what your quiz will look like. So if you can go through page 11 to 13 and you do well on it, and you're not being in trouble, you should feel the same way for tomorrow. Okay, all right, come get your phone.
Like that first one, it doesn't like ask what, like it's not asking for error.
Oh, sorry, yeah. I didn't say find area.
Oh, okay.
Right.
I was wondering.
I know, yeah, I forgot to, but I did include that on the key, so
Okay, so it's the error.
it will specify, yeah. It won't expect you to guess, yeah. I meant to say find the area.
We'll say about schools. About schools. Usually get that one. I don't know, like April, all the plans. Kind of scary. Got a lot harder to get. Oh. You know, how's everything? Yeah.
Good. How was your trip?
It was good. It was great. You see, yeah, we played at the airport string. Awesome. We saw so much stuff. We did so much in 2 days.
Yeah.
Saw that everything in. Competition, national archives.
Wow.
From White House, from the Capitol.
Everything was smoothly?
Yeah, one was from the Smithsonian Museum,
Yeah,
Air and Space Museum, and then we went to did a monuments tour.
wow.
And we went to dinner cruise as well. That was fun.
It's nice to come back and have a few days break, right?
Yeah, we had a day off yesterday. Came back to like late Tuesday.
Oh, we got back Tuesday, that was Monday, okay.
We didn't miss any school, which was good. We left like early time.
Right.
And, it was like a dark 10-hour drive. Got back at like 11 p.m. at school. Yeah. Yeah, ghost town there.
Back to there.
Yeah.
Everything was smooth.
Yeah. We did so much, like, we did like twice so much stuff in 2 days as like when my family went up there to elementary school. We did like twice as much stuff.
I bet, yeah.
I loved it. It was cold and windy too, so I was in my natural element.
You like it cold.
Everyone else didn't like it, but I liked it. The Hard Rock Cafe too. It was a Hard Rock Cafe too.
Oh. We still have those around, some of them have been like, shut down
Yeah.
over the years.
but also not, they never buy food from vendors outside
Oh, really?
in DC.
Not good.
No, like, went to the Aerospace Museum, like, the cafe they had there was too long a line, they made it go quickly. So our group went to the food trucks out there, oh, it was like, you don't know where to eat to go, I'm like, and I had boba tea and tasted like chemicals, it's like, I got mango boba tea, but yeah, they, you know, the food trucks. And like, I had a boba tea, it was supposed to be mango, but it tasted like Captain Crunch absorbed in milk. It was gross, oh. I was getting sick, luckily I didn't.
Yeah, hopefully no one got sick with that.
Yeah, they scare me too. Like, they seem so nice. It's like, hey, how's it going? And when they give you your change back, it's like, straight face, and you just move on. Yeah, learn my lesson very well.
Mm.
They all look the same too. But
Yeah.
but how to eat?
Yeah, had to eat, right?